Are we good? Okay, we're learning about arithmetic sequences today. Arithmetic sequences is basically a line of numbers, a sequence of numbers in certain order where we can begin with any number we want, as long as, in order for it to be arithmetic, that number has to change to the subsequent number by the same amount, and every subsequent number after that by the same amount each time in order for it to be arithmetic. We have to either add or subtract the same amount from one number to get the subsequent number, from that number to the next subsequent number in order for it to be arithmetic. Only add, only subtract. If we're multiplying and dividing, it's a different kind of sequence, and that's a different lesson for a different day. That's called the geometric sequence, by the way. That difference between one number to the next, whether it's adding or subtracting to, is known as the common difference. Okay, let me write it down so you can have it for your paper. Common difference. Common difference is also known as, and commonly referred to most often as D, the letter D. So the common difference is the difference between one number in the sequence to the next number in the sequence, to the next number, and to the next number. And that has to be a constant, adding 2 or subtracting 2, adding 3 or subtracting 3, adding 1/4 or subtracting 1/4. It's got to be the same from one number to the next. So let's say, I'm going to make one up. Let's say we're going to start with my favorite number, 8. This is not on your paper. Whoops. What is the first term of the sequence? 8. So that's my a sub 1. A sub 1 is known as the first term. And that is read as a sub 1. To write it out how you say it. This says a sub 1. What's the common difference of this sequence? How do I go from 8 to 10?
Minus 2.
Add 2. How do we go from 10 to 12?
Adding
Now,
2.
in order for this all to work and be happy and copacetic is this has to be the same. It is the same. Therefore, this is known as an arithmetic sequence. And that's on your paper. I don't need to write that down, do I? Do I need to write that down? Arithmetic, it's at the top. 4.5 arithmetic sequences.
No, we have that.
Okay, so this is known as an arithmetic sequence. What if I change this to a 13?
It's not an arithmetic.
It's not an arithmetic because plus 2 plus 2 plus 1 plus 3, that's not the same. It has to be just like something's linear with a slope. It has to be the same. So let me go back. 14, 16, plus 2, plus 2. 1, 2, 3, 4, 5. What's the sixth term of that sequence? 18?
Yeah.
Okay. You just add 2 to 16. If this is the first 5, the next one, the subsequent, what if I asked you for, like in number 9, it says then find the next 3 terms. What are the next 3 terms?
18, 20, 22.
Good. That's the next 3 terms. Good. So you're getting this. Our D, our common difference here is what? 2. What am I forgetting to tell you? Oh, a sub n, the nth term of the sequence. This is the last and final thing I need to tell you before we can get to work. The nth term just means any number in that sequence, its place in line. So like, let's pretend football players with jerseys on. The football player with number 8 on his jersey is in the front of the line. Behind him is the football player with 10 on his jersey. He's second in line. The football player with 12 on his jersey is behind number 10. Number 10 second in line, so number 12 is third in line. So their place in line is referencing the nth term. Nth is just the placeholder for where you at in line. Or if we talked about, anybody inquire in here? So you guys staying on risers, yes? Well, I would imagine that the front row of the risers, that's the first row, that would be n equals 1. Let's say there's 12 girls in it. Because risers normally look like this. This is the first row, this is the second row, this is the third row, this is the fourth row. And let's say we'll start easy. Let's say there's 8 girls in the first row of risers. Then let's say there's 10 girls in the second row of risers. 12 girls, 14 girls. This is all women's choir, by the way. Do you see what's happening?
It gets bigger and bigger. They add 2.
Yes, just like my sequence. First term, second term, third term, fourth term. First term, first row. Second term, second row. Why do we need to do this? Well, Mr. Tucker, when he's trying to figure out, I have 95 students that I've got to put on 4 rows of risers, how many girls can I have in each row of risers? This is going to help him figure that out. Okay, he's probably not going to employ this method, but it will help him figure it out so that it's as even as it possibly can be. Did you have a question back there? No? Okay. Uh-oh. Sorry for the technical difficulty. Yes, ma'am.
So for n, it would just be any number's place.
Yes.
So it doesn't matter which one you choose. It doesn't have to be like the one in the middle, the one behind.
Nope. Nope. And I don't know if now is the right time. I'm kind of nervous because I'm getting videoed. I don't know if now is the right time to say it, but we can equate the actual numbers of the sequence to y values. And the actual place in line, the n value, as the x values. If I were to graph this sequence, I would graph the point, let me put a box around this. I would graph the point 1, 8. I would graph the point 210. I would graph the point 312 because this is the first place in line, x is equal to 1.
Oh.
This is the second place in line, x is equal to 2.
Yeah, no.
This is the third place in line, x is equal to 3. You get what I'm doing here?
So then it'd be 4.
No.
What'd you say?
So the n you choose doesn't matter.
The n I choose doesn't matter. I can choose any n I want. But the n that I'm choosing is the x value, the place in line. Yes, sir?
How would this work with fractions? Because on the paper it says number 2 and it has fractions in it, so.
Well, you can have fractions and you can move forward 1/2 step or 1.5 steps.
Yeah, but the bottom doubles, but then the top adds by
2.
2.
Okay. So can you add or subtract the same something from one term to the next? So can you add something to 1/2 to get 3/4? One-fourth or 1/2 is equal to how many fourths? 2/4. Okay. So if the first term is equivalent to 2/4, and the second term is 3/4, how can you go from the first term to the second term? By adding 1/4. So let's check. If I add 1/4 to 3/4, what do I get? 1 whole. Is that the third term in my sequence? It's 5/8. So is this arithmetic?
No.
We could stop right there, can't we?
Right.
It's not arithmetic.
So
I do like how you saw the pattern though, Maximus. That makes me think you like math patterns and puzzles like I do. So what Maximus, if you guys all look at number 2 has the sequence of 1/2, 3/4, 5/8, 7/16. He sees that the top is adding 2 but the bottom is multiplying by 2. You saw that pattern. I saw that pattern. That's not adding or subtracting the same something. Therefore, that's not arithmetic. Is it warm in here or is it just me? It's just me.
I'm in a hole.
Oh, Abby says it's warm in here. So number 2 is not arithmetic. Why is it not arithmetic?
Because the third term is not a whole.
Because we're not adding or subtracting the same something from one term to the next term to the next term. Yes, Carson? How do you explain it? Why it's not arithmetic? Because the differences between one term to the next term is not constant.
Couldn't you just say there's no common difference?
You could say there's no common difference, yes. Do you know what common difference means?
Yes.
Okay, so then therefore you could use common difference in your explanation if you know what common
I
difference
was
is.
confused about fractions because I was like, would the top and the bottom have like their own common difference?
Well, but you could use fractions, like we could go from 1/2 to 1 whole to 3 halves to 2. What's the common difference there? A half.
Is there an I?
What did you say?
Number 4 not be,
You
Tell
don't think
me.
number 4 is arithmetic?
yeah,
Why do you say that?
because
Not
they don't,
arithmetic because the third term is not consistent or constant.
Remember that you're being videoed, so whatever you're saying, just remember that they're gonna hear that. Which is fine, I'm glad you're talking about
We're
that.
talking about spelling because you couldn't spell the word right.
Oh, okay.
So it's wrong.
Okay, so Tiger's asking me about number 4. Number 4 is negative 12.3, negative 9.7, negative 7.1, negative 4.5. Are these going up or down? It's technically going up because they're negative numbers.
Right.
So we're going to be adding something. It's kind of a trick question. What are we going to be adding? If you don't know because it's decimals, put it in your calculator.
2.6.
You're adding 2.6 each time. Good job, Carson. So 12.3 plus 2.6, does that give you negative? Well, does a negative 12.3 plus 2.6 give you negative 9.7? It does. And then negative 9.7 plus 2.6, does that give you negative 7.1?
Yes.
Okay, let's check negative 7.1 plus 2.6. Does that give you negative 4.5?
Yes.
So what is our common difference?
2.6.
2.6, therefore this is arithmetic because it has a common difference of 2.6. Yes, Brittany?
So for like, what's the difference between the common, like, wait, so for like 1 through 6, you put like yes or no?
For 1 through 6 on your practice, you're writing whether or not it's arithmetic. So I would put arithmetic, not arithmetic. If it's arithmetic, I would put arithmetic common differences 4, for instance, on number 1. For number 5, which we haven't done yet. Have we done that yet?
No.
For number 2, we've done number 2. Not arithmetic because no common difference.
And then you put like for like 9 and through 16. So
We-
like the common difference.
We have to find the common difference and then the next 3 terms. So we'll write, let's just go ahead and do 9. Can we do 9?
Yeah.
Okay. So number 9, 0.02, 1.08, 2.14, 3.2. How do you go from 0.02 to 1.08? At 1.06. Does that hold true for all of it? I agree. Therefore, you're going to write D is equal to 1.06. Okay? And it asks for the next 3 terms. So what comes after 3.2? 4.26. Everybody agree with Bree? You should, I do. What comes after 4.26? 5.32. And what comes after 5.32? 6.38. Yes. That's how you do that. The calculator is going to be your friend. You can use the calculator to determine what the difference is. I recommend you taking 3.2 and subtracting 2.14. And then you're gonna get 1.06. To check it, I would take that 2.14 and add one or subtract 1.06 to see if I get 1.8. Just to check myself. Yes, Keandre?
I know this is a bad time to ask. Can I go to the bathroom?
It is a bad time to ask. Can you wait until I'm done? You guys know it's a bad time to ask while I'm talking about the lesson. Yes, Carson?
So, when we're doing the math adding, is the correct way to just start from left to right, or is it okay to start from left to right too?
I would always start from left, from that number, and go to the right with my common difference. Now, to figure out the common difference, I always go right to left, but you don't have to. But figuring out the next term, it's always left to right. Yeah. So 9 through 16 says find the common difference. We did that. And the next three terms. Use the given arithmetic, this is 19. Use the given arithmetic sequence to write an equation and then find the seventh term of the sequence. That's where this explicit formula, which I'm going to take that sequence off, you need to have this explicit formula on your paper. So that you can use this every time you want to write an equation for an arithmetic sequence.
You've probably already gone over this, but what does n minus 1 mean? Like, what do we put in?
I haven't done it yet, actually. So, what'd you say?
What's A again?
A sub 1. You read
I know
it.
that one, but what's A?
It's just a placeholder.
Okay.
It's like x.
Yeah.
Yeah, kind of, sort of.
But for the N, it doesn't matter what you choose.
Right. A sub n is any number of the sequence. So that's read A sub n. Let me write that down.
It's a lot easier than last time.
Yeah, I agree. So this is A sub n, and it means any number in the sequence and I'm going to put x value because it's the placeholder. Like the place in line. So what is A sub 1 in this, what number was that? Number 9. What's A sub 1 over here?
0.07.
0.02. The first number of the sequence is A sub 1. The first term of the sequence. It's in placeholder 1. X equals 1, Y equals 0.02. The person behind them in line, placeholder 2, X equals 2. The Y is equal to 1.08. Okay? That'll be important when we need to graph these. So if we're looking at number, let's look at number 19. I don't know if that can see over there. Do you know? Can it see to the left of that?
A little bit.
So I should
Yeah.
move this maybe?
Yes.
Okay. So number 9, this is number 9 on your assignment. We need to write an explicit formula for it. Actually, we need to do, we'll use that as an example. No, we won't. We'll do 19. I'm going to erase it. Because number 19 is one you have to do. So let's do number 19. This is number 19 on your paper. Negative 3, negative 8, negative 13, negative 18. What's the common difference in that sequence? 5. So our D is what? Negative 5. What's our A sub 1? What's the first term of the sequence? Negative 3. We're going to use that common difference. We're going to use that first term in our explicit formula to write the equation so we can find the 7th term of the sequence. So A sub n equals, what's my A sub 1? Negative 3. Plus, what's my D? My common difference? Negative 5 times n minus 1. N minus 1. I need to explain that. Someone asked me about that. If n is the place in line, if this is the place in line, n minus 1 is the place in line behind my n. That might sound confusing, so let me use it as an example.
So is it just 0?
Hmm?
Is it just
So,
0?
Maximus and Edson, come up here. Come on. Edson, stay between me and Maximus. Okay, we're a real life sequence, okay? Maximus is A sub 1. He's A sub 2. I'm A sub 3. Well, if we're using Maximus in our equation as A sub 1, right here, this is Maximus. He's n minus 1. If I'm using Edson, nope, that'll confuse you, I'm not going to say it. He's right behind the n. If I want to know what the first term is, if n is equal to 1, he's n minus 1. If I want to know what the second term is, that's Edson. Edson's n equals 2. How are you going to get me? I'm right behind him. I'm Edson minus 1. It's saying that I'm right behind him. Does that make sense?
Yeah. No, no lie.
Is n minus 2, so
And-
minus 1 is what we're trying to find is thing before.
Huh?
If we're using what's before, okay, if Maximus is in our equation, and the common difference between Maximus and Edson is negative 3, and the common difference between Edson and me is negative 3, I don't want to include him by multiplying by my common difference of negative 3. Because we're already including him here, but we need to include everybody else after the first term. You can sit down. I'll explain it here in just a second. What if I want to find the 11th term of the system? We could sit and subtract 3 each time. Sorry, 5, not 3. I could subtract 5 each time all the way out to 11. But what if I wanted 111? Do I want to sit and take negative 3 minus 5, negative 8 minus 5, negative 13 minus 5, negative 18 minus 5, 111 times? No, I don't. So I need a starting spot. That's why we use the first term. Okay? And then if I want, what did I say, 111? Did I say 111?
So
I can't
n
remember.
is just the number that you're trying to find that's in place.
Let me finish my thought. I'm multiplying, aka subtracting 5, 110 times. Let me say that again. Because I started here at negative 3, and I'm using that as my first term, whatever term I want to find, the nth term of the sequence, the place in line, n is the place in line, the x value. If I want the 111th place in line, I want 111 minus 1. Why minus 1? Because I don't want to multiply the common difference 111 times, because I have to have a starting spot. I have to know where do I begin subtracting 5? I'm beginning at negative 3. So do you agree that when we multiply, that's repeated addition? Even if it's a negative number, because we can add a negative number. That's multiplying is repeated addition, yes? Okay, so we could write this out 110 times. If I want the 111th place, remember n is equal to 111? I don't want to multiply the common difference 111 times because I have to have my starting point. That's what n minus 1 is. Because I'm already including the first term in my calculation. We'll wrap our head around that. Let's now do the algorithm part. This is the understanding part. That's the number sense part. Let's do the I don't know what it means, but I know how to do it part that the two of you asked me for. And probably more people asked me for. The algorithm part. Let's just follow the directions. So we have our arithmetic sequence. We know the first term. We know the common difference. And I have given you, and you just got to trust me that I know what I'm talking about. I do, because I got it out of the book. I can read. We're just going to fill in blanks. I'm telling you that we can find any term of the sequence, that's a sub n, by taking the first term and adding it with the common difference that I'm multiplying with n minus 1. Now, right now, I was trying to explain where the n minus 1 came from, but I'm getting a lot of blank looks, so let's not worry about that for the moment. We'll understand it later. So now I got to distribute this -5, do I not? You wait, Miss Martin? Okay. So let's distribute that -5. Yes. Plus 5, right? Now this can be mathed a little further by combining my like terms. Are you guys okay if I put -5 in first?
Yeah.
So my equation for this sequence in number 19 is a sub n equals -5n plus 2. Notice, peep my common difference right there. See my common difference in -5n? The number in front of n, the coefficient within, just like, and I think I erased it, just like my y equals mx plus b. This number here equates with the slope. My common difference and slope are the same. You had a question, Sophie?
No.
Okay. So it tells us, it wants us to find the 7th term of the sequence. I'm going to use that 7. My n equals 7. So this is how I'm going to write it. Instead of a sub n, because remember n represents the place in line, the x value of the sequence. So a sub 7, and everywhere there's an n, I'm replacing it with a 7. So a sub 7 is equal to -33. Is that what you guys got? Should we check it out?
No.
I think we should check it out. What place in line is -18? What's the n of 18? -18? 4. So if this is 4, this one's 5, this one's 6, this one's 7. So -18 minus 5 gives us
-23.
good, Maximus. -23 minus 5 gives us
-28.
-28 minus 5 gives us.
-33.
Does it match?
Yes.
So we can do it the hard way. But remember, mathematicians are lazy. If there's a shortcut, we're going to do it. What questions do you have so far? No questions so far?
Who keeps laughing?
I'm going to pause the video if you guys don't have questions. You got a question, Carson?
Why do we have two?
Say again?
Why do we have two?
Say that one more time.
Why do we add two?
Why do we add 2? Oh, we took the explicit formula. You just trusted me where it came from. And we filled in our first term with our first term of the sequence. So we replaced a sub 1 with our first term. We replaced the d with our common difference of -5. And that's where we got this part right here. A sub n equals -3 plus -5 times n minus 1. I mathed it. I distributed this 5 here. -5 times n gives me -5n. -5 times -1 gives me a +5. And then I combined -3 and -5 to get +2. The 2 means nothing in this explicit formula. It's not our first term. If we wanted to check to see our first term, we could just do a sub 1 is equal to -5 times 1 plus 2. -5 times 1 is -5 plus 2. So our first term is -3, but we already knew that just by looking at the sequence. Yes, Peyton?
Where did we get 7?
Because we're trying to find
The problem says find the 7th term of the sequence. Any other questions before I pause the video? Okay, just stop it actually.